This is the screencast for the group Xagonal for the tender for the design of the control communication system for Ammonix. The planning process included tendering, designing, and building. A brief introduction about this tender. The tender document presents a design of control communication systems for Ammonix, whom is constructing a Haber-Bosch ammonia production plant in Trinidad and Tobago. It outlines the process control network design, justification, selections, etc. of each network layer of the new plant. The design entailed design of transmitters, process, and override controllers. For the override controllers, 3 control loops were added, each consisting of 2 override controllers. The override controller takes control of the manipulated variable from the normal controller through the use of a low signal selector. This prevents the process variable from reaching hazardous conditions. Override configurations consist of controllers that remain inactive until a process constraint or equipment limit is about to be reached or exceeded. For control loop 1, the gasifier requires high temperatures to convert fossil-based fuel into the byproduct gases. These byproduct gases can expand due to high temperatures and cause an increase in pressure. Therefore, 2 safety controllers are placed to monitor temperature and pressure. The safety override controllers are seen as PIC1 and TIC1 in the control loop. The normal controller maintains the flow using ratio control, while the 2 safety controllers are placed to monitor temperature and pressure. For control loop 2, the shift reactor requires high temperatures to increase the yield of hydrogen gas and carbon dioxide. This increased yield of gases cause an increase in pressure, and therefore 2 safety controllers are placed to monitor temperature and pressure. The safety override controllers are seen on this diagram as PIC2 and TIC2. The normal controller maintains the flow using ratio control, while the 2 safety controllers are placed to monitor temperature and pressure. For control loop 3, the ammonia reactor produces NH3 gas in an exothermic process. The combination in the ammonia reactor adds to the pressure within the reactor itself, and therefore 2 safety controllers are placed to monitor both temperature and pressure. The safety override controllers are seen in this diagram as PIC3 and TIC3. The normal controller maintains the flow using the ratio control, while again the 2 safety controllers are placed to monitor temperature and pressure. The override controllers. The output of the override controller decreased as the manipulated variable approached their set points. The normal controller and override controller outputs are compared, and the low signal selector chooses the lower of the 2 signals. The normal controllers will then be overridden to prevent the set point from being exceeded. For the design and choice of network topology and arbitration, there were many things that were taken into consideration. The network layers that were considered were the field bus level, control level, plant level, and enterprise level. For the field bus level of arbitration, at the field level, the field bus foundation H1 protocol is chosen. Token passing is suitable arbitration since it is normally used for field bus foundation protocol at field levels. The token passing procedure guarantees that the specific master node that has the token gets access to the bus for a defined time frame. The master node with access to the bus can request data from other master nodes or slave devices within the time frame. The master nodes are the field level controllers, and the slave devices are the field devices such as sensors and actuators. Once the time frame expires, the token is passed to the next field level controller. After the time frame expires, the current master node will pass the token to the next master node on the bus. The advantages of this selection is that it's a non-contention method, which means that each field level controller is given equal access to the network for a given time frame once it has the token, and there is no need for controllers to compete for access to the bus. Also, it's effective since there are less collisions due to one node having access at a time. Traffic flows in one direction at high speeds occur since token buses use logical rings. The third point is that it is a deterministic protocol, meaning that packets would always be delivered in a known time frame. And finally, the bandwidth is more utilized when load demand increases. The one disadvantage of this method is that the system can become slow for lighter loads since nodes would have to wait for the token to be free. It's very slow compared to the Ethernet. At the field bus level, the network topology chosen is bus topology. Usually token passing is used with either the bus topology or the ring topology. However, field buses usually use a bus topology. Therefore, the token bus would be chosen, which uses bus topology. Token bus uses the standard IEEE 802.4. For this topology, the master node with the token sends the message over the network and it is broadcasted to all connected networks. However, the message would only be read by the station addressed to, while the other stations will ignore the message. The advantages of this topology is that the token bus allows for priority of the main nodes and hence faster response time for more critical processes within that level. High priority messages are transmitted first and lower priority messages after. Secondly, it is efficient for one-to-many nodes since the master node broadcast messages to all connected stations. And finally, there's much less cable is required for this topology as compared to others. The two disadvantages of this topology are that packet losses can occur due to the complexity of the system, and propagation delays can increase with increased numbers of stations connected to the bus and due to the bandwidth being used to access the network. For the control level arbitration, the high-speed Ethernet was chosen as the protocol. Just like Ethernet, the Foundation Field Bus HSE uses a random protocol called CSMA/CD. Carrier sense multiple access/collision detection. This is chosen since it's specified in the IEEE 802.3 standard for Ethernet protocols. If a node has to transmit data, it would listen to the network and will start sending data once the network is idle. Once the network is busy, the transmitting node will wait a random time and then try to resend. However, if two or more nodes decide to transmit simultaneously by both interpreting that the network is idle, collision and corruption of messages can occur. When a node listens to the network, it can detect message collision and wait a random length of time to resend data. This random time can be determined using probabilistic algorithms such as the standard binary exponential Bacco (BEB) algorithm. The advantages are that low propagation delays for lighter loads occur since a simple algorithm is used for operation. Secondly, contention can be detected on the network when a node wants to transmit to the network by using CSMA/CD. Thirdly, no bandwidth is used to gain access to the network as compared to token passing methods. Fourthly, distance between workstation and hub is limited to 100 meters due to the size of collision domain being around 250 meters. However, traffic can be segregated within each collision domain and hence collisions in the network can be reduced. Finally, latency is reduced due to higher speeds of 100 megabytes per second used as compared to standard Ethernet. The disadvantages is that it's a non-deterministic protocol and therefore messages are not prioritized. And also for heavier loads, there can be excessive message collisions, which would lead to packet losses and time delays in sending data. The control layer for the network topology, a tree topology was chosen. It's a combination of a star and bus topology. It usually follows a hierarchical pattern where each level is connected to a higher level. This topology is suitable for the control level since it's usually used in connecting field buses operating at 31.75 kilobits per second. For example, the Foundation Field Bus to high-speed buses such as HSE. The two main levels of the hierarchy, starting from the lowest level, include RTU PLCs, and SCADA RTUs. The advantages of this topology are easy Easy expansion of the network. The control level network is divided into star networks known as segments, making the segment operation easier to manage and maintain. If one segment is faulty, the others are not damaged, and also error detection and correction is easier due to these smaller segments. The disadvantages are that once the central node goes down, the other segments are affected. Secondly, more nodes and segments make maintenance more difficult. And finally, more wiring needed, and therefore the topology is more expensive. The plant level arbitration. Profinet is used at this level. Profinet is an industrial Ethernet-based communication and hence uses CSMA/CD. This is used such that each device listens to the network, and when it is idle, it transmits data. Profinet has different versions, which has different levels of determinism. The advantages of using this are that there are less propagation delays when using real-time determinism. There are less message collisions since once two or more devices want to transmit data at the same time, the switch chooses which one should transmit first and temporarily stores the other frames until they can be transmitted. The use of the network switches can be used to create multiple collision domains for heavier loads and hence reduce the amount of collisions, thereby improving response time, having less packet losses and delays. Finally, switches can identify high priority packets and deliver them faster. The disadvantages are different modes of switching have different downfalls. The mode that transmits data without reading and processing entire frame to have faster rates would not be able to identify errors within the frame until after transmission, which makes it inefficient. A second mode of switching that reads and processes entire frame before transmission has higher latency and hence a slower network. The plant level network topology chosen was the star topology. Since the switched Ethernet is used, Profinet is very flexible with respect to the network topology that can be used. However, since it uses switched Ethernet, star topology would be considered since data to be transmitted must pass through switches first before being sent to their destination. Star topology also would be considered to allow efficient communication between a central node, SCADA, and other various nodes at the plant level. For the selection of technologies, the transmission method chosen was the 4 to 20 milliamp current loop. The figure above shows the general overview of these components. The RS485 standard was chosen and twisted pair cables under this standard were also selected. The figures above show the standard, the general standard, and finally, the HART protocol was chosen and isolators under the HART protocol were selected and justified. The figure shows a diagram of a general isolated two-wire HART transmitter, which was chosen to be used in this document. The manufacturer chosen for all devices and technologies was Endress and Hauser. For research of future technology and plans for migration, the wireless technologies chosen were Bluetooth, Zigbee, and ultra-wideband. For the Bluetooth, network speeds travel up to 3 megabytes per second. Physical wires are not needed. There's a master-slave network. The Bluetooth uses a 2.4 gigahertz band with a strong transmission. It's designed for short ranges, low power consumption, and low cost. One of the most sought-after technologies for automotive devices, and Bluetooth Special's interest group initiated a hands-free car system to facilitate products that have Bluetooth connections. Bluetooth has 3 different power classes, Class 1, Class 2, and Class 3 listed below. They have security features and standardized under the IEEE 802.11 15.1 standard. They allow for interface of CDs and DVDs with car speakers and laptops. The standards chosen for communication. The standards chosen were the Safety Instruments System Standards, SIS standards, Alarm Management and Design Standards, and Digital Communication Protocols. The three standards, SIS standards chosen were IEC 61508 and 61511. 61508 deals with functional safety of the electrical and electronic devices and prevents hazards which may occur on the plant. 61511 encompasses an instrumentation safety standard for industry. The IEC 62862 is a standard for the management of alarm systems and involves the HMI technology in industry. IEC 61537 is the physical/hardware aspects which must be ensured in industry. The IEEE standard relates to the performance of hardware, dielectric, self-supporting fiber cables and relates to the aspects which must be kept. For the digital communication protocols, the RS-485 The RS-422 2-wire and RS-485 2 and 4-wire were considered. To a bit about each of these wires. The 2-wire, the 422 2-wire system is designed to cater for one driver and 10 receivers, while the RS-485 system can allow for many drivers and many receivers. Servers, firewalls, gateways, and access controls chosen was another part of the design of this document. The servers are computer programs or devices that provide functionality and services for the client devices. At the enterprise level, we have the database, connectivity, application aspect, and web servers. The firewalls monitor the incoming and outgoing network traffic. It uses security rules on making decisions to allow or block specific traffic. Firewalls are placed at the enterprise levels, and this allows for remote access to the plant network. Software firewalls will be installed on enterprise servers, and hardware firewalls will be installed on workplace computers. The gateways include hardware devices which are found between the control and plant level, as well as between the plant and enterprise level. This translates the data received at one level from protocol to protocol. The access control is a security technique used to regulate who is authorized to access data and resources.